21. The following is the graph of f prime of x. Find the interval or intervals on which f of x is increasing and or decreasing. All right, this is a picture of f prime, and I know if I'm going to find increasing or decreasing, I need an f prime chart. So drawing my f prime chart, I'm going to be looking at f prime to f prime. I'm going to be looking at where's the derivative positive and negative, or above and below. So I notice that my derivative is above the x-axis until I get to b. So my f prime will be positive, and then from b to c my derivative is negative. So if I'm looking at, I know f is increasing, and the interval would be starting at a, so starting at a till I get to b, and that would be because f prime is positive, and then f will be decreasing from b, and then I'll stop it at c, and that will be because f prime is negative. Alrighty, number 22, discuss the concavity of this function. To discuss the concavity, we definitely need to get to y double prime. So let's get to y prime first. The derivative would be 4x cubed minus, if I bump that 3 out in front, these 3's are going to cancel, so I'll get 13x squared minus 16x. And then y double prime will be 12x squared minus 26x minus 16. If I want to find a critical number, I'm going to take that second derivative and set it equal to 0. That looks like an awful problem to try to factor, but I do know that I could divide a 2 out of both sides of my problem, and if I do that, I will get 6x squared minus 13x minus 8 is equal to 0. From here, I'm going to apply the magic number trick, so I'm going to start with 2 parentheses. I'll put 6x, 6x, knowing that when I'm done, I'm going to have to divide out that extra x that I put in there already. Then I always take the first number times the last number, which gives me negative 48, and then I think to myself, what times what would give me negative 48? Negative 8 times 6, negative 12 times 4, negative 16 times 3, and I could keep going. I want to know which one of those options would give me that negative 13 in the middle. It's going to be this third one that I wrote, so it will be minus 16 plus 3. I do know that I need to divide the 6 out. I notice I can't divide the 6 out of each one, so I'm just going to split this one up. I could divide the first one by 2 and the second one by 3, and notice that does make 6. So if I divide the first one by 2, I'm going to have 3x minus 8. And if I divide the second one by 3, I'm going to have 2x plus 1. Okay, if I set that equal to 0, if I set each part equal to 0, this will give me x equals 8/3. If I set this second part equal to 0, x will equal negative 1/2. So on my y double prime chart, I am going to have negative 1/2 and 8/3. Okay, from here, I'm going to plug, I think I'll plug like negative 2 into y double prime. If I do that, I will get a positive value. Next thing, I'm going to plug 0 into my y double prime. That will give me a negative number. And then if I plug in like 4 or something like that into my second derivative, I will get a positive number. So if I would like to discuss the concavity, I would say that y is concave up from negative infinity to negative 1/2, and then it's also concave up from 8/3 to infinity. And as long as I'm discussing, I would say that would be because y double prime is positive, and then y will be concave down on the interval negative 1/2 to 8/3, and that would be because y double prime is negative. Number 23, find the limit analytically. The limit is x approaches 64 of the square root of x minus 8 over x minus 64. The first thing that we always want to try to do is to plug in 64. So if I plug in 64, I'm going to get 8 minus 8 over 64 minus 64. That gives me 0 over 0. That doesn't mean that the limit doesn't exist. It just means I cannot do it that way. Since I have a square root, I know that the method that we were taught how to do this was to multiply by the conjugate. So that's exactly what I'm going to do. Okay, and then from here, if I multiply it out, the square root of x minus 8 times the square root of x plus 8 is going to be x minus 64. And then on the bottom, we're not going to work it out. We're just going to put the two parts together. And then I notice I can actually cancel out my x minus 64s. And if I do that, I'll be left with 1 up top, and then I'll be left with the square root of x plus 8 down below. And then I will be able to now, the reason I wanted to do that was so now I can actually plug in 64. So if I do that, I'll end up getting 1 over 8 plus 8, and that simplifies to 1/16. Okay, 24. I have cosecant x to the cosecant fifth of x, and we would like to find y prime. If I were to type this in my calculator, it would be rewritten as in parentheses cosecant x, and it would be raised to the 5th power. So if I'm taking the derivative, I'm going to have to use the chain rule. So I'm going to turn this into a u problem. So if I take the derivative, that would give me 5u to the 4th times the derivative of the u, and the derivative of the u would be negative cosecant x cotangent x. Hopefully you know those formulas. Okay, my last step is just to sub in my u. I am going to put the negative out in front of the problem because that's the proper place to put negatives. So I'll get u to the 4th, so it'll be cosecant to the 4th x, cosecant x, cotangent x, and then I notice that I can put these two together to make it negative 5 cosecant to the 5th x, cotangent x, and that is my derivative. Okay, 25, find the absolute maximum of this function on the interval negative 2 to 4. The biggest thing, the absolute maximum, is going to be the biggest y value that I will get on this interval. So if I want to find a maximum, I first of all take the derivative. So I'm going to take the derivative. When I take the derivative, I'm going to get x cubed minus 6x squared, and that is it. I next would like to find the critical number, so if I set the first derivative equal to 0, I think I will factor out an x squared, which would give me x minus 6. So my two critical numbers will be 0 and 6. And then if I look at my interval goes from negative 2 to 4. 6 is not on that interval, so I do not even need to consider that. Okay, if I'm doing absolute, I do not make an f prime chart. Instead, I want to evaluate because I want to find y values. I want to find the y value at the critical number, but I also would like to find the y values at the endpoints. Okay, so if I plug in 0 into the original function, I will get 7. If I plug negative 2 into the original function, I will get 27. And if I plug the original, the 4 into the original equation, I will get negative 57. All right, so if I'm looking for the absolute maximum, I'm looking for the highest y value. So the highest y value would be 27.